Just a minute. Is this one? Yeah, this is the tutorial sheet. So as usual, I will take you through line by line, and also do the last. There are 3 exercises at the very end of the tutorial sheet. I will do them also. Okay. And any questions you guys have, please feel free to use the chat room, right? So use the chat room to ask any or all questions you guys have, right? I'll be happy to answer whatever questions you may have. Right, so you can access this tutorial sheet on your laptop or whatever you have. Right, so let me close this. The first thing I need to do is to open R. So so you go into the start menu, and then you go down and choose R, choose the 64 version. So it will come up with this window, right? So in this tutorial, I'm going to talk about, okay, the first thing I'm going to talk about is, rep. Rep is short for repetition. So if you have a vector, say, containing these 2 numbers, sorry, these 4 numbers, then you can use rep. Okay, rep stands for repetition, right? So if you say rep x times 2, it will repeat x 2 times, as you can see. So you see, you have 322.57, 322.57, right? If you say times 3, it will repeat x 3 times. So 322.57, 322.57, and 322.57, right? And so on. Now, if you say repeat like this, what will happen is the first element is repeated 1 time, the second element, which is 22, is repeated 2 times, the third element, which is 5, is repeated 2 times, and the final element, which is 7, is repeated 3 times, right? Right, guys? You follow me, right? If you have any questions, please feel free. Now, if you say length out equal to 8, now the meaning of this command is to repeat x enough times so that the output contains 8 elements. So you have 322.57, 322.57. So you have the output containing 8 numbers. Now, if you change this to say 10, you have 322.57, 322.7, 322. So now the output contains 10 numbers, right? Okay, now if you say rep each equal to 3, here each element of x will be repeated 3 times, right? So you see that 3 is repeated 3 times, 22 is repeated 3 times, 5 is repeated 3 times, and 7 is repeated 3 times. All right. So that's what each does. All right. The next thing you can write, if you write this, you get the numbers 1 to 3. So if you say rep the numbers 1 to 3 times 2, you will get this. You will get the 1, 2, 3 repeated 2 times, right? If you say times 3, you will see 1, 2, 3 repeated 3 times, right? And if you say each equal to 2, then you see that each element is repeated 2 times. So 1, 1, 2, 2, 3, 3, right? And if you say times C like this, then here 1 is repeated 1 times, 2 is repeated 2 times, and 3 is repeated 3 times. And you can also apply the repetition command for letters, not just numerical numbers, but you can also apply for letters. So suppose you have a vector containing A and B, and you want to repeat A 2 times and B 3 times. This is what you will get. You see A is repeated 2 times, B is repeated 3 times. You guys okay so far? Please feel free to, if you have any questions, please feel free to use the chat room, okay? All right, the next command I'm going to talk about is SEQ. SEQ stands for, as you can guess, SEQ stands for sequence. Yes. Right, it's a short for sequence, right? So for example, if you say SEQ from say 2 to 8 in steps of 2, this is what you get. So it's 2, 4, 6, and 8. So what you've done here is to like a sequence from 2 to 8 in steps of 2. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. Now if you say by 3, you will get this. 2 plus 3 is 5, 5 plus 3 is 8, right? Now if you say 3.5, you will get only 2 numbers because 2 plus 3.5 is 5.5, 5.5 plus 3.5 is 9, which is beyond the range, right? It has to be within these numbers, 2 and 8. So you only get these 2 numbers, right? And you can also have a decreasing sequence of numbers, like from, say, 5 to 2 by minus 0.8. It will give you the decreasing sequence. So here you're going from 5 to 2 every time you're decreasing by minus a half. So it's 5, 4.5, 4, 3.5, and so on, right? Now, you can also have the length out. So for example, if you type length out equal to 6, what will happen is this. So here you have numbers from 2 to 8, and there are 6 numbers. As you can see, this sequence has 6 numbers, and these 6 numbers are equally spaced, which means that the distance between any 2 consecutive numbers is the same. You see, the distance between 2 plus 1.2 is 3.2, plus 1.2 is 4.4, plus 1.2 is 5.6. So these numbers are chosen such that they are between 2 and 8, and the total number of numbers is 6, and they are equally spaced, right? Okay, and you can also do the same, what I've done above, like this. Create the vector z, which is 1 to 5, and then say from 4 to 14 along with z. See, this has the same effect as the command the previous command. So here you have numbers from 4 to 14, and there are 5 of them because this one has 5 numbers, and these five numbers are equally spaced, right? So you can see 4 plus 2.5 is 6.5. 6.5 plus 2.5 is 9. 9 plus 2.5 is 11.5, and so on. All right. So this is another way of doing the same thing as above, using the command along dot width. Right. The next thing is, I think I already mentioned this, right? And if you write this, then you have a decreasing sequence 4 to 1. Okay. All right. Next page. The next page is, I'm going to talk about how to do summary statistics. So I'm going to go back to the website. This is the website. I'm going to read the Moses data. You may recall this from week 1 tutorial. This is the Moses data that gives the times. So let me copy this, right? And go back to R and paste it. I'm going to read this data, right? And let me call it Moses, right? right? And header equal to true because the file has a header, right? So I have just read the data Moses. As you can see, it has basically one column, except for the counter column. It has just one column, which is called time. So you should type a name or names of the data. It gives you the name of the column. And you should type Moses $time. It picks the column that you want, which is the data that I just read, right? Now, for short, let me call this T, right? Now, if you want to do the summary statistics of T, so for example, the mean of T is this, right? The median of T is this, right? The variance or the sample variance of T is this. The standard deviation of T is this, and so on. Now, there is a command called five number summary in in R. And I will explain what that means in a sec. Now, if you type this command, five number in brackets, the object, the data set, it comes up with these five numbers. The first number is the minimum. The second number is the first quartile. The third is the median. The fourth is the third quartile. And the final number is the maximum. So you should call this F and S. You can call the object whatever you want, but let me call it F and S. Right? Then F and S contains these five numbers, right? So suppose you want to compute the IQR. Remember, IQR is the difference between the third quartile and the first quartile. So that will be FNS at 4, which is the third quartile, minus FNS at 2, which is the first quartile. So IQR for this data set is 1.05, right? So it's the difference between 49 and 47.95. There's another command called summary that you can use, right? If you use this command, you will get this as the output, right? So the first value is the minimum, the second is the first quartile, the third is the median, fourth is the mean, the fifth is the third quartile, and the last one is the maximum. So compared to this command here, the five number command, comparing this command with the summary command, you see they are pretty much the same, except the summary command gives one more number, which is the mean. Whereas the five number command does not give the mean. It only gives the minimum, first quartile, median, third quartile, and the maximum. And the summary command just gives one more item, which is the mean, right? Right, now let me talk about the quantile function. The quantile function, in order to use the quantile function, right, this is what you do. Suppose you want the quantiles of the data at 0 probability, 0.25, 0.5, 0.75, and 1. Right? Now, in the notes I gave you, for the quantile, for the definition of the quantile function, I will always use type equal to 6. But there are other types also. There's also a type called 7, which I will explain shortly. But for this course, for the purpose of this course, I will always use type 6, right? So if you type this, this is what you get. So the 0% quantile is basically the minimum. The 25th percent quantile is the first quartile. The 50th percent quantile is the median. 75th percent quantile is the third quartile, and the 100% quantile is the maximum, right? Now, there's something called type 7 also. Type 7 uses a different formula. So it gives different results. Slightly different. They're only very slightly different, right? Because when you type equal to 7, it uses a slightly different formula for computing the quantiles, right? Okay, but for the formula that I gave you for computing the quantile or the quartile in the nodes uses type 6, type equal to 6. Okay. All right. So please stick to that. All right. Any questions so far, guys? Hello, guys. Talk to me. Hello, guys. Any questions? Thank you. All right. Okay. The next thing I want to talk about is Windows. Now, suppose you want to record a session, right? Suppose you want to record whatever you're doing, right? You can use this command, Windows in brackets record equal to T, right? That will record everything that you're doing. I don't want to do that now. Okay, so let me close this. All right, now suppose you want to open a new window. You can use this command, device new. It will open this window. As you can see, this is a window that I just opened. Now, every time you open a window, it will have a number in it. So as you can see at the top, there is a number called 2. So every device has a number associated with it. This device has number 2. Now, if you apply this again, it will open another device, and this device has number 3, and so on. All right. So every device has a number. Now, suppose you want to use this device, right, and not this one. You want to use this one. No, you can only one device at a time, sir, Mikhail. Suppose you want to use this device, right, for plotting, for example, right? What you need to do is the following. So you say device set equal in brackets 3. So this command will set this window for plotting or whatever you want to do, right? Okay. Okay. And suppose you want to close a window. If you want to close a window, you say device dot off. So suppose you want to close this window, then you use this command. See, it has closed. Now suppose you want to close this window, which has number 2, then you say device off 2 is closed. So now we have closed both windows, right? Okay. All right. One question: what does type mean? Yeah, type means basically different formula. So you should look at the bottom of page. Let me show you. Where is it? If you look at the bottom of page 2 of the tutorial sheet, it shows the difference between type 6 and type 7. It shows the difference in the formulas for computing the quantile between type 6 and type 7. So please read the paragraph at the very bottom of page 2 of the tutorial sheet. Okay. All right. The next thing I want to talk about is plotting. All right. Now, how to plot a bar plot. To do a bar, remember, bar plot is used for categorical data, right? So let me create a categorical data. So I'm going to create the following categorical data. So which contains the party names: Conservative, Labor, Liberal Democrats, UKIP, and other. Okay, and I'm going to repeat each of these. I'm going to repeat each of these party names by 369 for Conservative, 314 for 314 for Labor, and 75 for Liberal Democrats, 118 for UKIP, and 124 for other. So this is the data set that you get, right? You see, this is the data set that I just created, right? Now let me convert this data set into a factor using this command. I think I showed you this before in tutorial 1, all right? Now, if you type table for F, it will summarize the categorical data. So you see there are 369 seats for Conservative, 314 for Labor, and so on. Now, if you want to do a bar plot, what you need to do is simply use the command plot, and this is what you will get. See, this every bar here represents the number of seats the party has. So the Conservative has the largest number of seats, and Liberal Democrats has the smallest number of seats. Now, factor, I talked about factor in tutorial sheet 1 when I think it's about 2 weeks ago. Factor means when you have a categorical data with different levels, like in this case, you have 5 different levels for the categorical data, and you want to turn that into a factor, right? So that it can be plotted. You use the command factor. So in this case, factor in brackets polls converts the data into a factor so that it can be plotted, or you can use the table command to summarize the factor, right? Okay. I think I mean, you should look back on tutorial sheet 1. I talked more about factor in that tutorial sheet, right? All right, the next thing I'm going to talk about is histogram, how to do histogram. Now, you may recall this data set. This is the times data, right, for the from the Moses data set. Now, suppose you want to do a histogram of this. So you use the command hist. See, this is what you will get. So this is a histogram of the times data. On the y-axis, you have frequency. On the x-axis, you have the intervals, right? Now, if you want the density in place of frequency, what you need to do is this. You say frequency equal to false will produce this. Now, on the y-axis, you have the density. X-axis is the same, right? Now, if you want more classes, then I mean, at the moment you have only 7. You have only 7 different classes, right? Suppose you want more classes, say 14 classes, right? Then you use the command break. Sorry, 24 classes is too many. Let's go change this to 14. Okay, so now as you can see, the histogram has 14 intervals on the x-axis, right? And you can also specify the limits for each interval, like by using the sequence command. So for example, you want the intervals on the x-axis to suppose go from 47 to 51 in steps of say 0.4. This is what you do. So you see what I've done. I have, excuse me. You see what I have done. The intervals on the x-axis go from 47 to 51, and each interval has length 0.4. So the length of each interval is 0.4. All right, suppose you want, say, to go from, say, 46.8 to 50.8, then this is what you will get. So here, the interval goes from 46.8 to 50.8, and each interval is of length 0.4, right? Okay, so that's the histogram. The next thing I'm going to talk about, is the box plot. Now, to do a box plot, you simply apply this command, box plot in brackets T, right? And this is what you will get. Okay, you see the middle line is the median, and this line here is the first quartile, and this one is the third quartile, and this one is the lower adjacent, and this one is the upper adjacent. And I told you how to compute the lower and the upper adjacent. And the lower fence and the upper fence are outside the plotting region. They're not here. Okay. Okay. All right. So the next thing I'm going to talk about is to go back to the website and read this data set, runners. Okay, runners has 2 columns of data. The first column is p-mol, which is kind of a concentration of a chemical that is found in your body. And the second column is a factor, says they're successful or collapsed. So these are runners. So successful means that the runner was able to complete the race, and collapsed means that the runner was not able to complete the race. So let me read the data, copy and paste. Okay, so I'm going to read the data into an object called runners, right? Then read dot table, open bracket, open quotes, end quotes, then header equal to true, right? And now you should type runners. This is what you get. This is the data that we just read, all right? And you should type names in brackets, runners. The data has two columns. The first column is the PMOL column. The second column is the group, right? Okay. All right. The next thing is, suppose you want to do a box plot of the data, right? Then you use the command box plot, right? Runners. Uh, of the box plot of runners concentration versus runners group, and this is what you will get, right? You see, uh, there are two different box plot depending on which group it belongs to. So the collapsed group, the collapsed runners have a box plot looking like this for their concentration, and this is for the successful runners. So as you can see, the concentration level for the collapsed runners is much higher compared to the successful runners. And also the variability is represented by the length of the box, right? The length of the box tells you how variable the data are. So the variability for the collapsed runners is higher than the variability for the successful runners, right? Okay, so box plot is something very useful to compare the location and the variability of a data set, right? Okay, now suppose you want to pick, like, okay, let me retype the data. This is the data, right? As you can see, the concentration levels goes from 29.6 to 414. Now suppose you want to pick a particular subset of the data set that corresponds to the concentration being greater than 100, right? Now to do that, you use this command, runners with high concentration. It's a subset of the runners data set, right? With the subset corresponding to high concentration, okay? All right, now you should type this. You will see this data. You see, so what I have done here, guys, is to pick a subset of the data where the concentration values are greater than 100. So you have 7 people, 7 runners, each have concentration greater than 100. Okay. Now you should do a summary of this data, right? Okay. You will see this, right? You have 7 runners, all of them have collapsed, and 0 runners, none of the runners were successful. So this is not it's not needed because there are no runners who were successful. So if you want to drop this level, if you want to drop this level, you can use the following command. See, there's a command called drop levels, right, of runners, right? Okay, and now you should type summary. This is what you get. You see, the level corresponding to successful has been dropped because there were no runners who were successful. So we don't need those. So by using the drop level command, you get this, right? Okay. All right, the next thing I'm going to talk about is how to do scatter plot. Now, suppose you have numbers -5 to +5. When you use the box plot to plot two data sets, is it necessary for them to be of the same size? No, they don't need to be of the same size. No, I mean the data sets can be of different size. No, I mean, like you can have one data set, say 40 data sets, the other is say 20 data set, 20 numbers, so, and you can still plot them on the same graph. I mean, you can still plot. I mean, you can still plot the two box plots side by side on the same graph. All right. All right. The next. Okay. Suppose you have this data x -y to +y, right? And suppose you want to plot x versus y, which is x squared. And this is what you get. You see, and this should be something familiar to you. This is known as a parabola. I'm sure you know what I'm saying. Okay. Okay. This is known as a parabola. Um, Now, you can also add a line. If you want to add a line, if you want to connect the points by a line, you use this, right? So you see the thing, the plotted points have been joined together by a line, right? Here, here, this is not. You shouldn't confuse this with the one. This is not a one. It is actually L. L stands for line. So let me write it. L denotes line, right? Okay, not to be confused with one. Right now, you can also add a color. Suppose you want it plotted in blue. So you should say color equal to 4. You will see that it's a blue line, right? And different numbers corresponding to different colors. So this is purple. Color equal to 6 correspond to purple, and so on, right? One other thing you can do is, suppose you have a sequence of numbers from 4 to 5 with length equal to 100. So what you have here are data numbers from 0 to 5, and there are 100 of them, and these numbers are equally spaced, as I mentioned before. Now you can do a plot of x versus x squared with type equal to L and color equal to 2, and this is what you will get. So this is a plot of x squared versus x, right, for the points specified by this sequence, right, from 0 to 5. Okay. Now you can also, on top of, suppose you want to plot a cubic on the same graph. To do that, you can use the lines command, right? So if you want a cubic, right, this is a cubic, right? Say with color equal to 4, this is what you get, right? You see, the blue line is a cubic, is a cubic, and the red line is a quadratic, right? So you have the both polynomials plotted on the same graph. Okay. All right, guys. So this completes the tutorial. But now we have 3 exercises we need to do. So can you go to page 7, please? You should go to page 7 of the tutorial sheet. You have 3 exercises we need to do. The first exercise is about the simulated data set. So let me go back to the website. So you have this data set, which is this one. This is a simulated data set. You have a case number and X. X is the simulated data that we are interested in. So I'm going to copy this and paste it here. And let me read this data right into an object called simdet. Okay. All right, now so if you type simdat, you see I have just read the data that I showed you. All right, now if you type names, right, it shows the names of the two columns that I have just read. So the two columns are called case and X. So the column that I'm interested is X. So I want to pick that column and let me call it XS. I mean, you can call it any other name. I'm just calling it XS. Now I want to find the summary statistics of the data. So these are the 5-number summary statistics. So there's the minimum, the first quartile, the median, the third quartile, and the maximum. So if you call this FNS, FNS contains the 5 numbers. Now you can compute the IQR as the difference between the third quartile, sorry, excuse me, the third quartile and the first quartile. So the IQR for this data set is 2.64777. And you can also use the summary command, right? And if you use the summary command, this is the output that you will get. So this is the minimum, the first quartile, median, mean, third quartile, and the maximum, right? And you can also compute the variance using the var command. You can compute the standard deviation using the st command. And you can do a box plot of the data set using the box plot command. So this is what you get, you see. So here, they are both the same, Neil. Yeah, the back arrow key and the equal sign, they are both the same. But people prefer to use the back arrow key. I don't know, I can't explain why, but the back arrow key is more traditional than the equal sign, right? Okay, anyway, so this is the box plot for the simulated data set. As you can see, the data is slightly skewed because the median is not exactly halfway between the first and the third quartile. Now, if the median is halfway, then the data would be symmetrically distributed, but it is not in this case because, as you can see, it's slightly skewed because it's not exactly halfway between the two quartiles. Okay. All right. The next thing. So to answer Neil, this and this are the same. Okay. Okay. All right. The next thing is I'm going to do a histogram. If you do a histogram of the simulated data, it will look like this. Again, as you can see, it's not exactly symmetric, right? It's kind of skewed, right? Now you can change the frequency to a density scale by using the freq command. Yeah. So here you see that the y-axis is on the density scale, right? And you can change the x-axis, right, by using the breaks command. So suppose you say breaks is a sequence from 6 to 16.5 in steps of 1.5, and this is what you will get. So the x-axis goes from 6 to 16.5, and each bar has length approximately 1.5. Okay, all right, and you can change it as you want. Like you can try this, for example. All right, and this is what you get. Right, so here the x-axis goes from 6.25 to 15.25, and each bar has length 1. Okay. All right, so that completes the exercise 1. Any questions on exercise 1, guys, so far? The next exercise I'm going to do is exercise 2. Okay, exercise 2, you should read the tutorial sheet in front of you. It's about the Giza data set. Giza is like you have eruptions in the, I don't know whether you've been to the Yellowstone National Park in the United States. There are about 222 geysers. I mean, some of them like give you long and short duration eruptions. Now I'm going to read the data set. So let me go back to the website. This is the website, and this is the Giza data set. It has 3 columns. The first is the day column. The second is the duration of the eruptions, and the third is the interval. So let me copy this, right? Paste. Okay, and then say read table in this, and I'm gonna call this. Let me call it Giza. I mean, you can call it whatever name you wish, but and header is as usual is true, right? So this is the Giza data set. Now if you type names Giza, it will give you the names of the 3 columns that we just read. The column that we are interested in is the duration column. So I'm going to pick the duration column by using the dollar command. When you say dollar, the name of the column, it picks that column, right? So if you say dollar duration, it picks the duration column. If you say dollar interval, it picks the interval column, and so on. So let me call this XD, right? So XD contains the duration that we just read. Now, if you want to do a summary statistics of XD, you just stay. So according to this, the median of the durations is 4. The smallest duration is 1.7. The largest is 5.2. And you can also do the variability by doing the var or SD. And you can also do a box plot. You should do a box plot of the duration data. This is what you get. As you can see here, the data is very skewed because the median line is not even close to being halfway between the first and the third quartiles, right? Okay. Now, sometimes the box plot is not as informative as the histogram is, right? So let me do a histogram of the data, right? Now, if you do the histogram of the data, this is what you will get, right? Right. This is what you will get. You should do a histogram of the data. Now, let me use frequency equal to false and say breaks equal to say 16. Now, as you can see, this histogram is a lot more informative than the box plot is. It kind of shows that the distribution of the durations has 2 modes. There's a mode around this which corresponds to small durations or short durations, and there's a mode around this which corresponds to long durations, right? And the distribution is a mixture of mode. Mode means I thought, okay, did I not? Okay, mode is the point where the histogram is the largest, right? In other words, it's the point where the density is the largest. So as you can see, there's a mode around here and a mode around here, right? And this mode corresponds to small durations of eruptions, and this corresponds to long durations of eruptions. So the mixture, the distribution of the durations is a mixture of 2 different distributions, one for short durations and one for long durations, right? Okay, guys. Now let me. You can also specify the x-axis differently. So suppose you want the x-axis to go from 1.5 to 5.5 in steps of 0.0 to 0.025, and this is what you will get, right? And suppose you want it like this is what you get. Suppose you want it like this. All right, so in each case, what you see is the density is bimodal. It's bimodal with two different modes, right? Okay, so that completes the exercise 2. Any questions on so far on exercise 2? Hello, guys. Before I go to exercise 3, are you okay with exercise 2 or no? Okay, thank you, guys. Okay, the last exercise, which is exercise 3, is about anorexia. I don't know what actually it means, but I think it's something to do with the disease or something. This is the anorexia data set. It has 4 columns. It has 4 columns. The first is the case column. The second is the pre-weight. The third is the post-weight. And the last column is the treatment. There are 3 different treatments, as you can see. And the question here is, which of the three different treatments is the best? I mean, the treatment that is the best is the one that makes the largest difference between the weights before the treatment and after the treatment. So you see, this is the second column is the weight before the treatment. The third column is the weight after the treatment. And we are interested in the treatment that makes the largest difference, right? Okay, let's see how we can do this. So let's copy this. And paste it here, all right? Header equal to true. And let me call this anorexia, okay? Anorexia read.table, okay? And this is what you get. So okay, this is the data. So there are 4, as I said before, there are 4 columns to the data, right? And this is the data that I just read. Okay. Now I'm interested in the treatment. Finding the treatment that makes the largest difference in the weight. So let me call, just for short, instead of typing treatment all the time, let me call it treat. Now I'm interested. I want to know the difference between the weights before the treatment and after the treatment. So that's what I'm computing right now, as you can see. So DWT is the differences in weight after the treatment and before the treatment, right? Okay. Now I want to compute. I want to find out the weights corresponding to each of the 3 treatments, right? So let this object correspond to the differences in weight when treatment is 1, right? And let this correspond to the differences in weight when treatment is 2. And let this correspond to the differences in weight when the treatment is 3. Now I want to, one way you can find out which of the treatments is best is to look at the summary statistics. So this is the summary statistics for the differences in weight when the treatment is 1, and this is the summary statistics for the differences in weight when treatment is 2, and this is the summary statistics for the differences in weight when the treatment is 3. All right, now looking at these numbers, looking at these numbers, you should be able to say which one is the best. You see, because treatment 3 is the best, because you see that the median, which is 9, is the largest among the 3 treatments. The mean is also the largest among the 3 treatments. And the third quartile is also the largest among the 3 treatments. And the maximum is also the largest among the 3 treatments. So treatment 3 makes the biggest difference. In fact, to see this better, to see it even better, you can do a box plot. You should do a box plot of the differences in weight versus treatment number. This is what you will get. And this clearly shows what is happening. You see, this box plot is for treatment 3, this is for treatment 2, and this is for treatment 1. And you can see clearly that the differences in weight is largest when you have treatment 3, and second largest when you have treatment 2, and smallest when you have treatment 1. And hence, treatment 3 is the most effective, treatment 2 is the second most effective, and treatment 1 is the least effective, right? So box plot is a good way of comparing effectiveness of treatments when you have data like this, right? Okay. All right, guys. So this completes exercise 3. Any questions you guys have? Please feel free. Hello, guys. Talk to me. Are you okay with this or not? Are you sure? All right. So we are done with the tutorial sheet for today. And can I please ask you one more time that if you haven't completed the week 2 survey, can you please do so as soon as possible? Because the survey closes on Thursday, I believe, or Thursday or Friday of this week. So can you please, I would be most grateful. And of course, if you have any questions on this course or related, just feel free to call me or Zoom me or Skype me or email me 24/7, right? Okay. Have a good day. And I will post the video of this tutorial in the shortly, maybe within the next half an hour. I will post it in the course website as usual, right? All right, have a good day, guys.